All right, another integral property video that you didn't know you needed. This one's a bit more involved. There's a bit more going on with this one, so we actually have to build up to it. So let's start by considering part of the fundamental theorem of calculus, which just said that the integral from a to b of f of x dx is equal to an antiderivative evaluated at b minus an antiderivative evaluated at a. So if you're unsure about that, maybe go back and have a look at some integration videos. Okay, the next thing we can say is this. If we swap the bounds, so we're just going to be careful here because they look very similar, but there's a difference. So the integral from a to b, but down here we've got the integral from b to a of f of x dx. Well, if we do a bit of a matching exercise, there was a b here and that went first, and there was an a here that went second. So if we swap them, it's going to be f of a minus f of b. Okay, so we just sort of swapped where those a and b are. Okay, and so the next thing we can say is, all right, we'll keep the left-hand side the same. We're still looking at the integral from b to a now. All right, but what we're going to do on the right-hand side is actually going to take out a factor of -1. So if we take out a factor of -1 here, it's going to become positive f of b minus f of a. Okay, we're almost there. And so you can see, again, the left-hand side is the integral from b to a of f of x dx. But you'll notice that f of b minus f of a, we've already worked out what that was. F of b minus f of a was the integral from a to b of f of x dx. So I've just replaced f of b minus f of a with the integral from a to b of f of x. And we're going to put the negative out the front as well. Okay, and then our sort of grand finale is this. If we just move that negative to the other side, and then read it sort of from right to left, we get that the integral from a to b of f of x dx is equal to the negative or integral from b to a of f of x dx. And so, yeah, that's sort of our conclusion there. If we swap the bounds, we have to negate or make the whole thing negative. So just to show that I'm not talking nonsense, GeoGebra knows this fact. So if we were to look at this example here, we've got the graph y equals x squared, the integral from -3 to -1. So that would be sort of think about it like this. A is -3, B is -1, is 8.67. Okay, but if we swap the bounds, so essentially if we were swap the bounds to go from, we swapped them so to be from -1 to -3, we would get a negative area because the whole thing's negated. So let's have a look. If I do that, you can see, I've actually done it the wrong way. We need to do this one. We can see that if we take the integral from -1 to -3, so we swap the bounds around, we actually get a negative area. But it's got the same size, got the same magnitude, but it's actually a negative area. So GeoGebra knows what we're talking about, and hopefully you do now as well, because yeah, when we swap the bounds, we make the integral negative. Good stuff.